Hey, what's up, guys? Welcome back. Dr. Jaws here, and tonight we are meeting the Velvet Belly Lanternshark. So we're gonna go back into the deep sea, which is really exciting because we've been focusing on a lot of river sharks lately. So it's kind of cool to go back into deeper waters and to see another, or a brand new, I should say, brand new lantern shark. And no ads, no stupid ads. Sorry about that. But yeah, this one is Emopterus spinax. This is actually probably one of the more famous lantern shark species, one of the most well known, and there's actually a lot of research on it. So I'm excited to learn more about it. It's also really exciting to see that there's footage on this lantern shark species. So it's really cool to see. Whoops, that was actually a really short clip. It's really cool to see how these sharks move. They are, like other lantern sharks, bioluminescent, so they are able to emit this really beautiful light. And it depends on the species what that light is used for. Sometimes it's used for prey attraction, or more often than not, counter shading. So lantern sharks. Oh, this is actually really cool. This is a really cool clip. Lantern sharks do make DL migrations in the open ocean, so they will rise up from the depths every night. And the light that they have on their bellies is actually good counter shading for open ocean camouflage. So let's see if I can kind of reposition this so this is more centered in the frame. I feel bad. This new eCam update, it's unfortunately not so great. I don't know why it's screwing up with the camera angles, but I think this is a little bit better, so you can kind of see some of the action of lantern sharks at night. So, but yeah, so this species, like other lantern sharks or some other lantern sharks, will swim up from the deeper parts of the ocean, the midnight zone or the twilight zone, up to technically the sunlit zone, but at night. And so, in scenarios where you may still see a little bit of moonlight, or maybe even boat light. That counter shading on the belly of the shark helps camouflage it against the surface. So, and it's really cool to see a lot of this dive footage with this species. So, I'm just double checking some settings right now. So, cool. Okay, so. But this is actually really cool. This is so bizarre to see like a diver with a lantern shark, because I'm used to these species being deep water species, but it does make sense that they can come up. And I'm curious if this location might be like kind of more like a pelagic island, like a seamount kind of thing, because it's so cool to see divers interacting with this kind of shark. 'Cause it's typically a deep water. I mean, it is like a deep water shark, so it's not something that you should encounter. But this is amazing that like it's incredible to see like a human diver interacting with a deep water shark species. So. There's quite a few lantern sharks in the genus Emopterus. I think there's about 30 total. In Etmopterus, I want to say that's maybe 20 in that genus, but 30 species of lantern sharks are in the family Emopteridae. So it's really cool to see this group of sharks in life from even just from a scuba diving perspective. It's just super cool to see that there are some sharks that you can encounter on a dive that are typically inhabitants of deep water. Another famous example would be like 6-gill and 7-gill sharks. They are actually deep water species you can theoretically dive with. And then, if you have cold water training, like dry suit training for Arctic environments, you can theoretically dive with Greenland sharks as well. So we'll check out a couple more clips, and then we'll go into. This is actually really cool. This is I think a 3D camera arrangement, but. We'll check out a couple more clips, and then we'll go into lantern shark research. So I'm curious with this particular camera why it's a kind of like a double projection image, but it's really cool to see. So and I guess it's something to do with maybe 3D camera software, but really cool camera and the first shot. And we'll just kind of take a look at this dive. So this is by Christian Anderson. So just gonna like and subscribe to that channel. And I'll rewind right there because there are some lantern sharks. So it's kind of cool to see how many dive opportunities there are with this species. As you can see, it's a small shark and it's a little bit more sinusoidal in its movements. So it kind of reminds me of dives with pike dogfish, and they are distant cousins of these sharks. But unlike dogfish sharks, lantern sharks actually have smooth dorsal fins, so they don't have the spines on their fins like the dogfish do. This is actually a really cool wreck. I love seeing like the biofouling on shipwrecks like this, just kind of like all the marine organisms. And this is super cool seeing a chimera. This actually could be a kind of ratfish, like just swimming peacefully, calmly, kind of like almost like in a ghostly motion over this seabed. So it's pretty cool footage here. So. Hey Minjas, welcome back! Welcome back, hope you had a good weekend. We are diving in with the lantern sharks tonight, so this is Velvet Belly Lanternshark dive, so this is going to be really cool. Oh cool, so stereoscopic video, gotcha. So, yeah, I think this would be really cool with the right projector. I know it looks probably a little odd on YouTube, but with the right projector it would be really fun to, you know, kind of like watch this like like more of like an immersive experience. So but this is a really cool dive to see. Speaking of dives, I've scheduled I'm really excited to go diving in New Jersey this summer. I scheduled a dive in my original location was Shark River Inlet, but I think I'm going to be switching to another location nearby. But there's a high, or not high, but there's a probability of seeing some sharks, some dogfish sharks that I'm really excited to see. I think it is going to be pike dogfish, so fingers crossed. But I'm definitely going to take my GoPro, so I'm really excited for that. And we'll send any footage on the channel. But yeah, just super excited because the water is getting warmer over here, so you know, kind of getting back into dive season, and I'm just really excited for that. So. That's a beautiful coral, and I'm curious how deep these divers are actually, because I could see that this person has like a two. I mean, this still must be relatively shallow, but I can see this individual has like 2 tanks. So depending on how deep you are, that can buy you maybe 30 minutes underwater, because like the further down you go, the less airtime you actually have, because of how air contracts and expands. So this is a beautiful coral, by the way, and I'm not sure what species this is. And then here's a great shot of the lantern shark actually. So look at that. I love that you can see his like fins are a little bit translucent. And another cool thing about this group of sharks is that their skin, as we talked about before in other lantern shark species, is really iridescent. So it's this beautiful, like purplish color. Their bellies are a dark, velvety color. So when they are not emitting, these are really cute sharks. When they're not emitting bioluminescent light, you know, they you know probably offer that color pattern probably offers a different kind of counter shading. Or somehow probably aids with their camouflage, because it is really interesting to see. Actually, you know what? Maybe the black belly kind of helps make the blue light shine a little bit even more clearly. I'm not really sure why they have this pigmentation counter shading where, you know, their backs and their sides are very, you know, iridescent, beautiful, and purplish, and then their bellies are very black, or just like straight like jet black, and until they light up. So. I'm not sure why that is, but it's a really unique look. It's a really beautiful group of sharks. Great close-up of this chimera. I love the intricate pattern. And you can actually, this is a really cool group of chondrichthyans, so it's really cool to see how this is a very distant cousin of sharks and rays, but you can still see similarities, just kind of like with that flow, that cartilaginous fish kind of movement. Like all cartilaginous fish, they just swim there's just something about their movement that is just very, you know, unique and very like smooth and elegant. It's hard to describe. So, just catch up with comments. Awesome. Glad to be able to watch tonight. Hope you had a good weekend too. Thank you. I appreciate that. Been busy this weekend, so just kind of doing a lot of yard work and, you know, just busy. So, but following weekend, I think I might go hiking. Maybe snorkeling, I'm not sure, because the water's still really cold right now, so we'll see. But here's, just in case you missed it, Minjas, here's a kind of more close-up view of a lantern shark. So Velvet Belly Lanternshark in action. So again, it blows my mind that you can actually dive with this species. There's also a really cool. Let me zoom backwards. There's actually a couple of cool invertebrates in this shot too. So, okay, so we've got the Velvet Belly Lanternshark right here. Great close up of this beautiful little animal. And then there he is again. There is a sea pen. This vertical organism is a sea pen. It's actually really cool to see. And then that little round thing, I want to say that's a kind of urchin, but it's a very unique group, or it might be a cousin to sea urchins. I really should know what that is. I don't think it's a sea hare. I think because I think sea hares are nudibranchs, but I think that was a very unique group of urchins. There's another sea pen right there, and then this is some kind of little lobster. This one looks a little strange. It's not like the northeastern, like the New England lobsters that I'm used to. This is kind of cool. It kind of has the texture of a spiny lobster, but the shape of a New England lobster. So I'm really curious. I'm just going to pause. Where is this dive? This is by a YouTuber named Morten Gjelstad, and there's no description, unfortunately. Oh, here we go. Diving Velvet Belly Lanternshark. Yeah, but yeah, there's no description on where this is. So very curious though, because there's a lot of cool wildlife. There's a really awesome flounder right there, so well camouflaged. That looks like a squat lobster or spiny crab. A couple more lantern sharks. It's so cool to see them. Great shot of him coming up to the camera. And you know what? I think I made a mistake with this group. I am so sorry. So look how they actually do have dorsal fin spines. So I think I got them confused with sleeper sharks. Sleeper sharks are the ones that don't have the spines. So I don't know if you were here for that. I mentioned that lantern sharks, comparing them to dogfish sharks, and apparently both have spines. So I made a mistake. So sorry about that. It's a cool little crab. And it's actually really cool to see. This crab has modified back legs that is like a swimming crab. So blue crabs are like this. So that's actually pretty cool to see. Lantern shark coming out from the darkness. It's just so cool that he's very interested in the light. So he is going right up to the diver. It's a great collection of footage. There's a, I assume this is a kind of lobster. It's so small that I wonder if it might be a slightly different group. It looks so different from, again, lobsters that I'm used to, but some more sea pens. So really cool invertebrate. It's amazing how many different kinds of animals are in the ocean, and that most of the things that look like plants are actually animals. Like there's very rarely plants in the ocean. Really cool shot of these lantern sharks. Look at them. This is amazing footage. But yeah, there's only a few species of plants that actually can survive salt water, and the list is really short. So over here we have like eelgrass and other kinds of seagrass, and that's kind of it, really. Because the rest are seaweeds, kelps, and those are not plants. They're algae. And then, whip coral is an animal. There's just a lot of animals in the ocean, so. Oh, this is cool. Minjas, this feels like deep ocean footage for some reason. I'm surprised you can dive with it. Yes, so it's actually really cool. So I think this is a night dive that's taking advantage of kind of the biology of this group of sharks, where they do come up to the surface at night. Because a lot of their prey items will undertake these deal migrations, so they will actually come up to the surface from the depths at night. So the sharks are going to follow them, and there might be some unique locations in the world where divers can encounter these sharks in shallow water, but only at night. It would be very rare to see it at the daytime, so it's super cool. And then Minjas, I think sea pens, and these ones I learned about are Nidair. Oh, cool! Cnidarians, like jellyfish relatives, which is weird, honestly. So actually, what's interesting about that? And thank you for reminding me, because I was kind of confused what group they were in. But what's really cool about that is the classic jellyfish that we're used to. They kind of actually start, or not start, but there's a phase in their life cycle that does kind of have like this tower stack phase. So let me see if I can point that out. Jellyfish or sea nettle life cycle. And that's actually really cool that sea pens are cnidarians, because that makes there we go. This is a good example. This is not quite a sea nettle, but I'll take it. So. Man, I hate that table change. It's image balls. It's really annoying. Okay. Okay, this is what I wanted. Okay, there we go. Acceptable. Okay, so this is actually really cool. Connection with sea pens. So jellyfish, the jellyfish that you all are familiar with, they're technically a kind of plankton. So plankton doesn't refer to the size of something; it refers to how it navigates water. Where if it's at the mercy of the currents, it's a plankton. But if it can swim on its own and actually go through the water, it's a nekton. So all fish are nekton. Actually, not. Well, sorry. All adult fish are nekton. Some juvenile fish are plankton because they can't move. They just kind of float with the water. So jellyfish are plankton because they don't have enough power to kind of like move through the water. They can pulsate and float, but they're really the thing that dominates their distribution is the ocean currents. So that's what makes them plankton. They're huge plankton, but they are technically plankton. So what's really cool is that jellyfish, like the jellyfish that we know, the ones that sting us and that we see on the beach, they release these little larvae called planula. And these little things kind of fall into the seabed and turn into a polyp. So it kind of does turn into this like towering little thing. It's very small, but it's kind of cool to compare this with a sea pen, because a sea pen, which is also a cousin of jellyfish, like you pointed out, Mingus, its whole life cycle is kind of like that, that vertical structure. But it's kind of cool to see that jellyfish actually in life, there is a phase where they have that. So jellyfish have this polyp phase. Sometimes they resemble sea anemones, which is also a cool connection because sea anemones are also cnidarians. The polyps turn into these like little buds, like kind of like pancakes, stacked on top of each other, and eventually the buds kind of fall off and drift off to become Ephyra, which is like a really tiny, adorable, minute jellyfish. And the Ephyra eventually grow up, they get bigger, they get more robust, and they actually turn into the adult jellyfish that we know. So it's actually really cool to see that there are some commonalities between just like the sea pens, like the adult sea pens that are living their lives. Let me see if I can get them back in this video. And a phase in a jellyfish's life. So yeah, there's some sea pens right there. So very different because, I mean, like a jellyfish polyp is probably very small comparatively, but it's really cool to see that there's like a similar sort of thing going on. So, the weird little strobola phase. So, oh yeah, it's really confusing actually because it's like I think plankton, it is largely dominated by like the microscopic organisms, so it's very funny. It's very unusual to think of jellyfish as plankton, and then also think of like SpongeBob SquarePants, where it's the tiny dude. but plankton. It's actually really cool that the term plankton, it refers to just the relation of an organism and how it floats or swims in the water. If it floats, it's plankton. If it's in the mercy of the currents, it's plankton. If it can swim against the currents or swim, independently, it's nekton. So it's really cool. So, let's see. I got so excited about that I might have missed the sea pens because I think there was a really cool shot. Oh, there we go. Yeah. There we go. So that's a really cool shot, and like, look how like alien these look. These are so cool looking. So relative to the divers, they're about like maybe 3 or 4 feet tall, maybe 3 feet tall. So that's actually really cool. So. Oh man, beautiful sharks, beautiful sharks. I'm so glad we have some footage on them. There's one more clip to take a look at, and then we'll dive into some of the biology. So this is more of a velvet belly lantern shark in midwater, eating shrimps. So that's actually really cool. You can see its jaws kind of like snapping up some shrimp. So we'll slow that down for a better view. And this is, I see a diver's hand. So this is a shark that's actually really close to a diver. So this is also a shallow water setting. So that's really, really wild to see. So. Alright, so let's go ahead and slow that down to see if we can see some of that feeding action. So this is about 50% speed, or half speed. And there he goes. So you can see him kind of snapping. Let me see if I could zoom in on this for an even better view. All right, so we're gonna go to the top right. He'll swim into the top right corner of the frame so that we can see him snapping up a shrimp. There we go. There we go. There we go. So it's such a cool shark. Let's do this one more time. Let's see if we can get a really, really nice close-up. Might be a little too close. Alright, we'll see him appearing in his zone if I position this right. There he goes. There he goes. Yeah. This is such a cool shark. Alright. I'm gonna do one more time. One more time. There we go. I just want to get the right shot. Okay, there's his fin. Okay, there we go. So, super cool seeing him snap up some shrimps, some squimps. So, and it's really amazing to see how these sharks move, because they are reminiscent of dogfish, but they are a lot more like, kind of like, not, I don't want to say eel-like, but you know, they do kind of have that sinusoidal movement a little bit. So it's super cool to see them move through the water. Okay, so we're going to take a deeper dive into... Hey, Bibia! Welcome back! Welcome back! Hope you're having a good morning. Let's see. Precambrian explosion type of animal. Sorry, I just saw that comment from Ninjas for the sea pens. Yeah. Super cool. So, yeah. Bibia, since I think you recommended the lantern shark, let's go back, and I do want to make sure that we see the footage, because I think you recommended this species last week. So we've been talking about how cool it is that there are some dive opportunities with lantern sharks. So we'll take a look at this. I think this is probably like the best clip of them, and then we'll dive into the research and the conservation. But this is a shallow water habitat at night, and this is an opportunity to dive with Emopterus spinax, the Velvet Belly Lanternshark. So, what's kind of cool is that in all of these videos, we've seen, or most of these videos, we've seen not just one, but a few individuals suggesting that there is actually maybe a school. So if you see one lanternshark, much like its cousin, the dogfish, it's probably a good bet that you'll probably see other individuals maybe of the same school. So this clip, this night dive, is really cool, where you get to see, we were talking about some invertebrates, like sea pens, which are those vertical, thin, white things, that little lobster in that frame. Again, there's the Velvet Belly Lanternshark just cruising. This is super, super cool to see. Fun fact, night diving is a... Oh, nice flounder again. Night diving is kind of a specialist skill. So you do have to take additional training in order to do night diving. Which makes sense. It's very disorienting. Like all diving is disorienting. Like that's the interest. Oh, this is really cool. Look at him come close to the camera. All diving is disorienting because the underwater world is it just feels so different. It is very different from the terrestrial world. So your sense of balance, your sense of spatial awareness, it gets a little bit more confusing. And night diving, especially so, it's very hard to kind of get your lay of the land or lay of the sea, I guess. It's very hard to find your waypoints and set your waypoints at night, and just diving in general. So unless you're very well practiced with it. But anyway, so yeah, night diving, just as fun trivia, is an additional skill. It's an additional specialty that you have to train for. So I don't have that specialty. I'm still pretty basic comparatively. But I love this lobster just kind of sizing the camera up. So and a crab sizing the camera up too. They're both checking it out. It's a really cute shot actually. And those are the sea pens we were talking about. This really unique group of animals. Actually, it's really cool to see them, and see how large they are. So the diver comes into frame a little bit, but they get to be a couple feet tall. So there's 2 lantern sharks, both swimming into the frame. Beautiful animals. We were talking about their beautiful iridescent purplish bodies with the jet black bellies that turn bright bioluminescent blue when they emit bioluminescence. So yeah, we'll go ahead and learn more about them. Speaking of, is the dive opportunity specifically at night because the species only comes out at night? Yes. So that's a great question, Minja. So yes, so for deep water sharks like this, some of them do come up to the surface only at night because they're chasing prey items that are used to dark environments. So when the sun sets, some prey items kind of float up to the surface because they don't really they feel like they could still hide in the darkness. So it's a deal migration where there's some prey items that are getting closer to the surface at night, and their predators follow them up. So lantern sharks do that. 6-gill and 7-gill sharks can do that. There are opportunities for people to dive with those species, and then I guess Greenland. I mean, I shouldn't say that Greenland sharks do that because Greenland sharks are a deep water shark, but they appear in shallow water in cold environments. So I guess that's not a good example. I think probably one of the cooler examples, and actually one of the scary examples, would be cookie cutter sharks. I don't know how many people who've dove with them, but there are humans who have encountered them in Hawaii in open water. There have been shark attacks by cookie cutter sharks. Only a few, maybe 3. But it's people, going out in the open water at night, and maybe a party boat or something. They're like, "Oh yeah, let's go swimming. This is so nice, beautiful." And then they don't realize that cookie cutter sharks are in the water because they're coming up from the depths. And there have been some bites, cookie cutter shark bites. So, which makes me I never want to do that. I never want to swim in open water in Hawaii at night. And actually, that's a very dangerous prospect anyway, because there's actually, Hawaii is a nice tiger shark hotspot too. So it's just not a fan of that. And oceanic white tips. So not a fan of that. But anyway, let me also get up. I have to tee up the IUCN Red List so we can learn more about the species conservation. I think many lantern sharks are least concern, so I'm curious if this species is like that too. Spinax. This is one of the most well-known lantern sharks, and this is actually kind of sad. This is a vulnerable species. So Velvet Belly Lanternshark, one of the most well-known lantern sharks in the world, is vulnerable. I'm a bit surprised by that. So let's check out what is making the species vulnerable. So its range is in the eastern Atlantic, the west coast of Africa, Mediterranean, Iceland, Norway, the British Isles, so the western coast of Europe, so the northeast Atlantic. Also this really cool triple junction zone near the Azores. So what is going on with the species conservation-wise? Let's find out. The Velvet Belly Lanternshark is a small deepwater shark found in the eastern Atlantic Ocean from Iceland to Gabon and the western Mediterranean Sea. It occurs on the outer continental shelves and upper slopes at depths of 70 to 2,000 meters and mostly from 200 to 500 meters. So this is mostly a Twilight Zone kind of shark. The species is frequently reported as incidental catch in deepwater demersal trawl, longline, and hardline fisheries across its known spatial range in the northeast Atlantic and Mediterranean Sea. Off West Africa, there are a number of European distant water vessels using demersal trawl and longline to target demersal fish and shrimp species that likely interact with this species. So unfortunately, I guess for fishermen at night who are getting, shrimp head fish, shrimp, it sounds so dumb, but fishermen at night, you know how we talked about this shark swims up to the surface at night. So maybe, unfortunately, these sharks are running into night like fishermen at night who are operating at night. The Velvet Belly Lanternshark is listed as a deepwater shark species in European Union regulations, and various management actions apply to such listed deepwater sharks, including a prohibited on target fisheries as total allowable catch for shark bycatch and longline fisheries targeting black scabbard fish, and the depth limits beyond which gillnets and demersal trawl fisheries are prohibited in some areas. Overall, there is a high distribution overlap with intensive fishing pressure, some refuge at depth, and deepwater shark management across parts of its range. So the negative is that it's running into fishermen who are operating at night, but the positive is it's a deepwater species, so for the most part it gets to avoid a lot of human pressure, and there's some active management for it. Overall, there's high distribution overlap with... Oh, I'm sorry, I already read that. The Velvet Belly Lanternshark is estimated to have undergone a population reduction of 30 to 49% over the past 3 generation lengths based on abundance indices and actual levels of exploitation, and is assessed as vulnerable. So that's really concerning. It's not as bad as endangered, but it's still really concerning because it's a lantern shark. So that's a deep water shark, and you'd think that these sharks universally across the board would probably be safe from humans. So it's really sad to see that Etmopterus spinax, might not be doing as well compared to other species. So yeah. And for comparison, what was it? 30 to 49% population reduction. That's really bad. But there are some shark species that have undergone like 80 to 90%. Sometimes, typically 70-80%, so it's not as bad as other shark species, but still not good. So let's learn more about the shark's biology. And it's really cool that you can get some great photos of it too. So I love this comment, Minjas. Just God, it's so cute. Yes. Oh, I just saw this comment. Maybe it's my own dumb mind, but you're not dumb, Minjas. Don't say that. But I'd rather be one-shotted by a bull shark than get a chunk taken out of me by a cookie cutter. I agree with that. That would be a really nasty bite to sustain. That would be an awful bite to sustain. So yeah, I definitely agree with that. I definitely get the reason behind that. So the percentages though are scary. Agreed. So it's sad because it's like, it's actually really freaky. I think we talked about this a couple streams ago, but it is really freaky that when you think about human population growth and you plot it against like the decline of certain animal populations, it's really freaky. It brings me comfort when there are sharks that are doing okay, like the Port Jackson shark is doing okay, or a lot of deep water sharks. I don't know what happened there. Are doing okay. So, but it is really freaky to see population reductions and then in tandem human population increases. So, it's just kind of sad to see. So, here are some interesting photographs of the lantern shark. You can obviously see a parasite. So this is like a gill parasite, and this looks like a kind of a isopod or copepod. So what's interesting for future shark researchers, parasitology is a pretty, active field. There's actually quite a few shark parasite studies. So, but I know it's kind of gross, but here's a really good picture of just the what's the word? The difference in the color pattern of the shark, where you have like the beautiful purplish. I know this individual is kind of faded, but like this purplish iridescent sheen on the back, and then where the shark gets its namesake, the velvet belly, like the just deep, almost reddish, almost jet black. Velvet belly, where the bioluminescent pores are, which help the shark glow this really beautiful blue. So it's a really cool color pattern, very unique amongst sharks. We'll go back. Let's see if make sure I didn't miss any pictures. These are fishes. Actually, this is a little odd. I don't know why. These are minnows. I don't know why they're in this thing. I guess it's there are other additions to that collection. But anyway, Emopterus. So the Latin name is Emopterus spinax. Greek Emopterus is from ethmos, sieve or ethmoid's bone, and petron wing. So it looks like the genus name is sieve wing, which is kind of strange and kind of sad because it's like there's so many other things you can call it. Like it would be cool if there was like a Latin name for, like bioluminescence or glow in the dark or something. So like a lumos shark or something. So. And then spinax, they don't explain it here, but I'm assuming it's probably to do with the fin spines. This is probably one of the first lantern sharks ever discovered, so if I'm not mistaken. So it's probably the researchers may not have realized there's actually quite a few lantern sharks with spines, or all of them have spines. So let's see. Kind of talked about the distribution. It's Iceland, Norway, Western Mediterranean, and Morocco, Senegal, Sierra Leone, Cote d'Ivoire, to Nigeria, Cameroon, to Gabon, Azores, Cape Verde, Cape Providence, South Africa. It's a very small shark, so 60 centimeters total length, and not even a kilogram. If I got that, yeah, not even a kilogram. So like nearly 1 kilogram. So very, very tiny. I'm going to quickly convert centimeters to inches. But really, really itty bitty shark. I think some of the small sharks in the world are in this family. Centimeters to inches. I know Google allows you to do this. There we go. Just doing this on my phone. So 24 inches. So not too small. So pretty. It's about 2 feet, so at maximum size, but overall average size of the shark is really, really itty bitty. Found on the outer continental shelves and upper slopes, feeds on small fishes, squids, and crustaceans. Ovoviparous, with number of young ranging from 6 to 20 in a litter. Utilized for fish meal and prepared, dried, salted for human consumption. So, and there's always not a lot of info from FishBase, but it's a good starting point to learn more about the species. This is really cool. So you could see that for any kind of scientific name, if you see like the Latin name of an animal and then the parentheses, the name inside the parentheses is the name of the author of that animal, or that animal's name. Like Linnaeus is actually the I guess he's called the father of taxonomy, but he's the person who invented the entire classification system for plants and animals. And it's really cool to see that there's actually a few sharks that are named by him. Like there are a few shark species that Linnaeus himself examined, took a look at, and assigned a scientific name to kind of help categorize them and organize them as we conduct research and learn more about biodiversity in the world. So it's really cool to see that all authors are in the parentheses next to scientific names, if you ever see that. And it's really cool to see that Linnaeus himself is the author of this species. So Linnaeus is the author of Emopterus spinax, and this species was described in 1758. So one of the oldest shark species known. So that's actually really cool. Oh, holdable shark. I really like that comment, Mingus. Kind of fun trivia question. Can anybody name, I think there's contention about this, but what is the oldest shark? What as far as like a scientific name goes, what is the oldest scientific name as far as sharks go? Like any guess on like what species would count? And there's one answer I'm thinking of because I think it's Gunnarus is the person who described this species, and I believe it predates some of the Linnaeus sharks or all the Linnaeus sharks. So there's one that I'm thinking of specifically, but there are actually quite a few sharks that have extremely old names. So if you have any guesses, please let me know, and let me know in the comments. Let me know your guesses. What are some of the oldest sharks known to man? Like the oldest species names known to man. Hey, okay. I'm assuming that's Mako Shark, and you might be right. I think it's not the one I'm thinking of, but that's a really good guess. It's actually really cool to do detective work too, in terms of like thinking, what are sharks that people probably would have encountered close to shore, or have seen near the surface. Yeah, the maki shark. And actually, there's a really cool thing. There's a really cool trick. I'm gonna give the chat more time to make any guesses if they want to, but there's a really cool trick to cross reference. So we'll take a look at that in a little bit. So we'll give a couple more minutes. This is actually really cool. So Linnaeus's classification, the original description came from the Systema Naturae. So this is one of the oldest books, and it looks like they don't have any illustrations or anything from it, unfortunately. But they do have, kind of like a diagram of the species. Let's see. Common names for the shark. Sometimes it's called a velvet belly, just velvet belly, velvet belly lanternshark, or velvet belly shark. The Schwarz, the Schwarzer Lanternhaie is a German name. It's kind of cool. Zagrino is an Italian name. I love these names. There's actually a really cool collection of names here. So, let's see. Oh wow! Okay, check this out. Look at this. This is an amazing CT scan of the lantern shark, and it's a little. Oh, sorry. We'll go back. This looks a little creepy, but it's actually really cool. These are the eye cartilage. So sharks actually kind of have like these. Oh, you know what? I can't. Yeah, no, that is the eye cartilage. So eye socket cartilage. So actually, wait, hold on. I want to make sure I have that right, as opposed to the olfactory bulbs, because sharks have in their chondrocranium, they have olfactory bulb cartilage. But they can also have, depending on the species, eye socket cartilage. So, but it's really cool to see, those right here. I know this is a really freaky image, and you can see the teeth here on the lower jaw and the Meckel's cartilage. And well, this image is kind of freaking me out a little bit. You actually have these really cool tricuspidate teeth. So they kind of look like Raphael, like the Ninja Turtles, like Raphael's knives, or sais, like Japanese sais. So they're actually really cool looking. The lower teeth, they look to be interlocking, kind of like kitefin sharks a little bit. Oops, sorry, let me go back there. I wonder, it's such a nasty continuous blade, so kind of like almost like a chainsaw. So, even though this shark is small, it can definitely pack a powerful bite. Hey, Roy, welcome back. Let's see, Carcarinus. Oh, I'm gonna start this comment. I really appreciate this comment. Where's Howard? Yeah, because Howard is on every stream, so I hope he's doing okay. But I'm gonna start that comment because we love having him here. So, but Carcarinus is a really good guess. So Minjus guessed Mako. Roy guessed Carcarinus. So it's not the one I'm thinking of, but I think it's a really good guess, and you might be right. So thank you, Minjus. I'm actually like part German, kind of. So it's really weird because it's like my ancestors are just, it's so far back that it's just dumb to say, but I'm a little Irish, or like a little like equal parts Irish, German, English, I think French / Canadian, because like my grandmother's mother's mother used to live in Nova Scotia, so she was one of the first Canadians, so which is awesome. Go Canada, because we have a lot of Canadians on our channel, so it's really cool actually. But Canadian, French, Irish, English, German, and I think that's it. Scottish maybe, but it's this like Germanic French thing going on. So a Germanic Celtic Irish French thing going on. So oh my gosh, Howard is sleeping. I love this. Howard is sleeping and dreaming of sharks. That's awesome. So I'm gonna start that too, because pillar of our community. Yep, absolutely, absolutely. So, all right, I'm gonna unveil the trick for cross-referencing. Oh wait, sorry. This is really. What is this? Whoa. Okay, so I actually do know what this is. This is really cool. Let me try to put this back into frame so you guys can see this. This is really cool. Okay, I'll show the trick in a second, but I have not seen this in forever. So this is fish staining. So what it is that you stain. You can use. I forget like the specifics on how this works, but you can actually inject certain. I'm trying to think the right way to say this. I think certain proteins. I want to say a specific color. And what you do is that, and they used to do this, they still do this, but they did this in the fisheries lab at the Virginia Institute of Marine Science. What you do is you take your fish, like a normal fish, slowly inject, and like a dead fish. They never do this. Well, I think they rarely, I don't think they ever do this to live animals. I don't think they would ever do that. But for a dead fish, you take like a normal fish, whatever fish you could think of. We'll just take the shark, and you have it's like it's purplish brown skin. It's like it's black belly, everything. You inject it with certain chemical, certain colorized agents, and I think they are. I forget if they're like radioactive or if they're kind of like. And when I say radioactive, I don't mean like toxic. It's just that there's a way that the colors like can show up and appear, and you don't need special equipment. They actually appear as is. So you somehow kind of like attach a color to a certain kind of protein, and then you actually depigment the skin and the muscle tissue. So you actually make everything translucent, so you can see specific structures. So for this example, you can see that they tagged the cartilage this beautiful turquoise blue. They tagged the dermal denticles a red, which when you kind of apply it to the body, a reddish orange. You can see that the dermal denticles are really widely spaced. The cartilage, you can see the blue structure, kind of coming through. They tagged like the eye socket. So this is eye cartilage. There we go. The eye socket yellow, and then they actually tagged the teeth purple. So and it looks like they might have tagged the jaw cartilage purple as well. So what you get is this really great diagram of how all these pieces work together. So this is called fish staining, or just like specimen staining. So so again, you attach colors to certain proteins or certain I think it's proteins. You attach colors to certain proteins, and then you depigment the skin so that the skin becomes translucent, kind of like looking through a window. So you can kind of better understand an animal's anatomy. So it's a really cool process. It takes a very long time to do it, but it's really cool. I just saw this comment. Dr. Jaws, aka descendant of one of the first Canadians. Appreciate that. Oh my gosh. So didn't know it was possible with larger vertebrate species. Yes. So and what's kind of cool is like I'm not sure the size limit. But I feel like this shark fits right in that range where this can. Thank you, Bibia. Just saw this. I think the shark is right in that range of the specimens I used to see, because I've seen them do it to flounder and stingrays, but like little ones. So that can fit like on it, like probably in the palm of my hand. So little specimens. So I'm not sure. I'm curious if there's like larger specimen staining. So, but there's such a really very interesting image. I definitely wanted to click on it. So before moving on. So okay. So here's the trick that I was referring to. So which is really dumb, but it works. So you go to Wikipedia and list of sharks. This is so dumb, but for whatever reason, Wikipedia has the most updated list of every single shark in the world. It's really unbelievable. And what you can do is you can go back in time. So let's just do 17. Is there anyone from 1740? Okay. 1750. Okay, there we go. So 1750, we can find the Linnaeus sharks. So the shark that I was thinking of with the oldest name is the basking shark, because I did see a report from, or not a report. There was a book that listed the author as Guineris from 1745. So I believe the basking shark, in that respect, is the oldest named species, but sometimes they go back and forth on that, where I think they say that the basking shark was named by Linnaeus in 1758. So the one I was thinking of is basking shark, but there's a couple correct answers. So let's see who some of the first sharks are. The sharks that were discovered, by Linnaeus, like the father of taxonomy. So we've got this species, the Velvet Belly Lanternshark, Emopterus spinax, in 1758. And by the way, this is wild. This is before America. like these sharks are older than the United States. Isn't that amazing? Like, it's before the United States, before 1776, before 1783. It's before America. It's unbelievable. Sharks predate America. I mean, like, not even just sharks, because sharks predate everything, or at least everything human related. Sharks biologically, evolutionarily predate everything. But sharks, as far as like humans starting to learn about sharks and name them and understand them and assign names to them, it's older than America. This is older than the Declaration of Independence. It's so wild to think about. So, we got the Velvet Belly Lanternshark, 1758. The Angular Rough Shark, 1758. That's amazing. I'm shocked, actually. Because rough sharks are like these really deep water species, so I'm really surprised that that's actually one of the oldest ones known. Squalus, as the entire genus, 1758. The spiny dogfish, or pike dogfish, Squalus acanthius. Of course, that totally makes sense. It is a classic. It is like, the goat of shark research. Like, I probably misused that term, but like, it's the most well-known shark in the world, so it makes sense that it's one of the oldest, so... The angel shark, Squatina squatina, the original classic angel shark, totally makes sense that this is from 1758 as well, so it's really cool to see that. Let's see. The great white, Carcharodon carcharias. There is something that, it does bring me a little bit of joy, that the most famous shark in the world is also one of the oldest, as far as the species names go. We've known about great whites for 3 centuries, nearly, so it's just... Yeah, it does kind of, it brings a little twinkle to my eyes. It's cool, so. Minch's guest, Mako shark, and actually, that's not too far off, 1810, so that's actually still a really old genus, a really old group, and this is the famous short fin Mako, so that's a really good guess, Minchus. Prionus glauca, the blue shark, 1758. So it's another very old species. So it's really cool to see that, and that's a classic too. Blue sharks are pretty popular in the shark zeitgeist, I want to say. So the small spotted cat shark, Scilurhinus canicula, interesting, but I believe the species is found in the British Isles. So I think it kind of makes sense that it's one of the oldest, because I believe a lot of modern oceanography is rooted in British oceanography, I want to say. I think the thrust of a lot of oceanography came from Great Britain, and then it slowly kind of shifted to the United States, and then slowly became more and more globalized. So the nurse hound totally makes sense. Same reason. This is another species from the Eastern Atlantic. The bonnethead shark, Sphenotivero. I'm actually pleasantly surprised by that. That's really cool, because bonnethead shark is a American shark. It's a North American, and I guess technically South American species. So it's kind of cool to see that that was also, as old as it is. And the smooth hammerhead, Sphena zygina, also really cool to see that that's an older species. The taupe shark, Galeorinus galeus, a very famous shark from Eastern Europe. And then the common smoothhound, same thing as the other 3 British Isle sharks. This is something that was close to British waters, so it makes sense that this is an old shark. So those are the original shark species, or original, like the first described shark species. So it's a mix of like 12 species. I really love these comments. By the way, I'm just reading these. So yeah, um, yeah. Taxonomy is older than America. Yep, yep, yep. Mako are cool. I like their teeth. Yep. OG sharks. I love that comment. Love that comment. Yep. So it's so cool to see that there was a group of 13 sharks. So well, I guess 12 sharks. I was about to say it's like the 13 colonies of America, but 13 sharks. 12 sharks really. Actually, let's count these. How many the original sharks? How many are they? There are 1, 2, 3 because Squalus is a genus. 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, because we're back to Emopterus. So 12 original shark species. So super cool. But yeah, for any fun, if you ever want to make a list or look up sharks from different years, like different time periods, let's find a mid-2000s shark. Because I was reading an article today that people were getting excited about. What was it Revenge of the Sith and then the Oblivion remake? So let's see, 2005. Heterodonus omensis was discovered. The Oman bullhead shark is 2005. The Australian weasel shark is 2005. Let's do 2014. This is the year I graduated. Short belly cat shark. That's cool. So it's really cool to see that like you can find different sharks from different time periods. It's actually the thing that I think is so humans whaler shark. What is that? What's really cool and very exciting about this is you usually get at least one shark species a year. And you definitely get a few in a decade. So it's actually very encouraging that there's still a lot of new sharks to discover, a lot of new species to discover. So yeah, darn, so close to having 13 colonial sharks. Yeah. Oh my gosh. So let's go ahead and check back with the lantern shark. And I think it's hard to believe it's almost 10 already. So I think what we'll do is I do want to check out Andy Merck's dive notes on this species because it's amazing that there's a deep water shark that people can dive with. So let me make sure that you guys can see. Man, I cannot wait for Ecamm to update because I don't know why it's being as goofy as it is. Okay, this is better. So here we go. It's kind of better. Let's see. Can I make this slightly better than that? Okay, I'll take it. Okay, so this is Sharks and Rays. This used to be known as Elasmo Diver, but this is famous shark photographer Andy Merck. He's amazing. One of the best in the world, I would say. So, and he has this really cool website. Let me put it in the chat so you guys can take a look at it too. Really cool website on Sharks and Rays. He's kind of made a visual compendium of Sharks and Rays, but he also has dive notes on them, which is really cool. So, Velvet Belly Lanternshark. Let's see. A small shark species with a long, bluntly rounded snout, large green reflective eyes, and 5 very short gill slits. First dorsal fin small and low, with a rounded apex and anterior fin spine, and is equal to or less than half the length of the anterior dorsal margin. I won't read all of this because these are more specific descriptions. So, dorsal coloration reddish brown or dark brown. Ventral surface covered in black photophores. Photophores may appear green under artificial lights. All fins pale near their bases, fading to black near the margins. So, let's see. So beautiful shot, amazing photograph of the species right here. So, and you can see, just how large the eyes are. So perfectly adapted for its deep water environment. I love the head shape too, where it kind of like the head is almost like entirely like this big eyeball, really, and yet you have this like upward curving mouth. That as we saw in some of the clips earlier of the shark feeding on shrimp. Definitely capable of capturing prey items. These cute little fins right here, so little pectoral and pelvic fins, but a not so cute, very long fin spine on the second dorsal fin, much longer than the first. I love this kind of like bluish, kind of like, it almost looks like spray paint on the caudal fin. Just a really cool set of colors here. This is actually, we said it before for lantern sharks, but this is a really beautiful group of sharks where you have like iridescence on the top, these really cool accents on the sides, like these blue accents here. And then this like really dark velvet belly that actually can bioluminesce. So and just really fish-like in a way. Must be the extreme iridescence. That's a good observation. I agree that it is probably the iridescence that kind of gives off that fishy texture, if you will. Also, if I'm not mistaken, I think lantern sharks' dermal denticles are kind of more spread out, so that might also contribute to that as well. So we talked about this before, but we'll reiterate. This species is vulnerable. So the Velvet Belly Lanternshark is a bycatch in deepwater trawl, longline, and handline fisheries in Northeast Atlantic and Mediterranean Sea. Demersal trawl and longline vessels in West Africa probably caught this species as well. In Europe, there are management actions for the deepwater sharks, and this is relating to black scabbardfish fisheries. And the Velvet Belly Lanternshark is estimated to undergo a population reduction of 30 to 49%. So this is kind of straight from IUCN Red List. So another great photograph of this shark, and this is a better view of that beautiful purple iridescence. So really gorgeous animal. And then there's two of them in this frame, so it's actually really cool to see. Kind of like a schooling behavior too. So. Deepwater trawling, my beloved. Yes, 100%. And just as one big thing that I think is a really good message to spread is just reconsidering your seafood choices. Kind of figuring out where certain seafood comes from. Was it ever called a sardine shark? Yeah. That's a great question. Probably not, but that would be a good name for it because he is so small. But I will say it is such a unique animal. Actually, I really like just noticing this feature. And I'm going to get back to fisheries in a second, but love seeing these really distinct ampullae lords, electromagnetic pores right here. It's really cool. But anyway. But I think one big message for sharks, because we think about what we can do to help sharks, and I think some of the best things we can do as individuals are learn more about them. Reconsider our consumer choices. So when we go to the supermarket. Do we want to choose fish, or do we want to switch to maybe chicken or vegetarian or something? Something that may not be seafood related, or if it is seafood related, just making sure that it's from a sustainable source. For me personally, there are some salmon that are pretty good. As far as salmon that is sustainably fished and everything and managed. But when it comes to shrimp, I'm really nervous about shrimp because trawling for shrimp is really destructive. I mean, it's and farming for shrimp is also destructive. It depends on where it is. This is probably a good time to plug Seafood Watch. So hold on, Seafood Watch. So Seafood Watch is a good source for kind of they have these really cool little dining cards that you can print out and take with you in a restaurant. So if you ever go out or to the grocery store. If you ever go out somewhere, it's a good little thing to, wasn't there an app website you use to track that sort of thing? Yes, I think this is it actually, and I think the comment might have been there we go. So, but yeah, Seafood Watch is very helpful for that. So it's a good little thing, just to kind of cross-reference. So, and full disclosure, if I'm a guest somewhere or if there's something special, I'm a sucker for crab cakes. I sometimes go out and have seafood. So full disclosure, but in my daily choices, I try to avoid it personally. Where it's I focus more on terrestrial meat or my brother is vegetarian and I should probably learn more of his ways. Just kind of you have choices, and it's I think being conscious of your choices and even just cutting back a little bit can have a very positive impact. So that's a way to help sharks. Learning about them is a way to help. And then also finally, just really doing our part. Anytime we go to the beach, if you see trash, even if it's not your own, if it's plastic especially, it's very helpful to go ahead and pick it up. It's a really, really good thing to do. Every time I go hiking, and snorkeling and whatever, I will see just plastic on the beach and I will pick it up, because it saved something. If you pick it up and remove it from the environment, you do help at least one or two or three. You never know how many animals you might be helping. So, it is a very beneficial thing to do. And also, I mean, trash is sorry, not trash. Plastic is, relatively clean-ish. By the time you get to it and it's washed up on the beach, depending on what it is. Especially if it's like balloons. Balloons are terrible. But it's fine. You're not picking up like a disgusting cigarette or something. You're just grabbing plastic. So and you can recycle it. So. But picking up trash, being conscious about seafood, and learning about sharks, I think those are really great things that individuals can do. And I think they're empowering things. They're good choices. So, yeah. Plastic trash, same thing. Yeah. Yeah. So, and thank you, Bibia. No worries. I just saw your comment about watching from the beginning. So thank you. Appreciate that a lot. So, let's see. So this shark, the Velvet Belly Lanternshark, temperate continental slope is its habitat, usually demersal, but sometimes well above the bottom. Listed as occurring from 70 to 2,000 meters, but juveniles and possibly adults enter shallower water, 35 meters, in Norwegian fjords where sunlight is blocked by surface runoff. Now, that is interesting. Also, I have like space video game soundtracks in the background, and that one was kind of getting weird. It was like a Mario thing. Anyway, but I like the whole deep water theme, so I kind of had like a space thing going on. Anyway, this is really interesting. Norwegian fjords are a really cool, unique environment. I forget if they're always estuaries or if they oftentimes are estuaries, but if I'm not, let's see if we can see the profile of one, so I could just kind of show you what this is. Norwegian fjord images. Yeah. Oh. Befit the Bioluminescence species. I love that comment. Let's see. So fjords are these really cool. I guess this is like. I wonder if I can get like a good diagram of one. But okay, so fjords are these really cool, unique areas that are gorgeous. Like you have these beautiful mountains, right? But in the middle is ocean water. And it's a really cool environment. I guess it depends where you are, but let's see. Fjord cross section. But it's a really cool ocean environment that. Let's see. Okay, that's a little better. That's kind of. I'm trying to find a way to explain this. Okay, this is it. This is what I'm trying to find. There we go. We've noticed some unusual traffic coming from your network to continue. It's me. It's Dr. Jaws. I pull down so much shark information in this household. So many sharks all the time. Anyway, okay. So this is a diagram of a fjord. It's a really cool environment. So it's this very narrow, like these mountains. It's like a glacially carved environment where these like mountains have this like indentation in the middle, and you can kind of see the cross section here where there's open ocean water, and it flows in like into this like very narrow space, and then there's rivers that kind of flow out of it. So the shark website's Fear This Man. I appreciate that. So rivers flow out of it, the coastal currents flow into it, and the dynamic of this environment is that you create this like interesting little ledge right here. That what happens is that the water gets shallower and shallower and shallower, leading up to the entrance of the fjord. And then once you get into the fjord, you actually go into this drop off of deep water. So it's really cool. It's kind of like this weird like. The best way I could describe it is like it's kind of like a lake that's open to the ocean. If that makes any sense, it's like semi-enclosed from a depth perspective. So it's a really cool environment. So bring all that up to say it's really fascinating to see that fjords apparently are a place where you can dive with this species. So Norwegian fjords where sunlight is blocked is a place where you can find these kinds of sharks. And I'm imagining that this is where maybe a lot of these videos and photos come from, are these fjords. Fun dive fact, 35 meters is kind of deep. That's actually beyond my current skill level. So that's going to be more of an advanced scuba diving because, as you get further and further down, you get a little sillier and you get a little bit more disoriented, and you actually get a little bit it depends on where you are, but you're more at risk for nitrogen narcosis, which makes you kind of feel a little tipsy, a little drunk. It's called the rapture of the deep. It's a very scary condition because you do not want to be silly far away from the surface. It's a very dangerous thing. So but anyway, oh, that's awesome. Midges, being an adult and learning about new biomes feels weird, but also that's awesome. Yeah, I mean, honestly, I love that, because I'm in my 30s, and I honestly I've learned so much more now than I really even did in my 20s, and it sounds so strange, but as far as the ocean goes, there were some times that I felt like I knew everything I needed to know, and then, I would kind of dive into a specific subject that opened doors to other subjects. Wow, I had no idea. One of my favorites was eDNA, which I had no idea that was a thing, but you can apparently find fragments of DNA in the water column of sharks, and it's kind of like a detection technique for sharks being in an area that you may not have seen them in or have captured them on cameras in. And it's just such an amazing thing that I've never heard of before. I will say that I kind of feel like it's not really anyone's fault, but I kind of do blame. I think ocean popular media is a little bit to blame because he mentioned, thank you, because when we're growing up, when you have kind of educational books and stuff, like ocean themed books for kids, right? You cover the basics. You cover the open ocean, the coral reef, the midnight zone, or the twilight zone, the deep ocean. You the polar zone. You cover basics, and then most nature specials, they kind of still focus on an expanded part of the basics, but you keep reinforcing almost the same message, kind of over and over again, the same creatures over and over again, the same eye-catching whatever over and over again, and it creates this weird fixation. So it is to blame in a way. Yeah. So because it's if it gets too hyper fixated, then it's not widely applicable, and therefore there's probably not a lot of financial interest in it as far as and I'm trying to think of nature specials and maybe marine life books. But yeah, it is. But like you said, it is to blame in a way because what happens is you create this illusion that, well, I guess the ocean is just polar bears and great whites and orcas and that's it, right? And then the reality is it's far more complex, and it's really exciting, just how much is there. So I love and shout out to YouTube in general, because honestly there's a lot of really cool small channels, this one included, but there's a lot of really cool dive channels. So if you focus on a specific animal or a specific location, you can pull up a lot of great material and dive into this really cool thing. And one thing I will say about YouTube that I really like is YouTube's algorithm. It feeds off of what you put into it. So when you start looking for little specific environments, I've been kind of studying seagrass, just kind of brushing up on seagrass studies. This one included an anemone. Yeah, and sorry, I just love these comments, guys. Appreciate it. And also I appreciate that comment, Bibia. Sorry, I just saw that one, so I'm gonna star that. But I've been brushing up on seagrass, and it's opened the doors to oh yeah, seahorses live in seagrass. Oh yeah, this flounder lives in seagrass, and it's so on and so forth. So a lot of cool stuff. I highly recommend getting nature books or finding nature resources that are regionally specific. because it opens up a lot of cool stuff. So I think for the first part of this year, I'm just really super diving in Chesapeake Bay. I think maybe at the end of this year, I want to study more about the Gulf of Maine, maybe the Gulf of St. Lawrence. So I think focusing on specific regions can open up a lot of cool doors. So and kind of showcase like smaller animals that or small like unique details of an ecosystem that may not have been apparent before. Life in the Chesapeake Bay, which I'm just gonna do a plug for this. It's not mine, but it's really good. It's this Osprey one. This book is called Life in the Chesapeake Bay, by I think was it Alice and Jane Limpson or Robert Limpson. But it's really awesome. It's actually a really good introduction for not just the Chesapeake Bay, but also shallow water environments on the east coast of the U.S. So from Cape Cod to Cape Hatteras. So if you're interested, it's super cool. I highly recommend it, and it's exactly what I'm talking about. Where it's kind of like a really great resource to learn more about shallow water ecosystems. And it includes some sharks in it too. So, but I think regional guides like that are just really, really cool and very helpful. So as far as like kind of diving into like discovering new ecosystems and stuff. So, but yeah, sorry, that was a really long tangent, but we love our tangents. So we'll go back to the fjords. So fjords are really cool environments. I've never been to one, and I really would love to see one someday. It's just such a unique area. And let's see. Apparently, the juvenile Velvet Belly Lanternsharks can enter these fjords, which is extremely cool. Tangent lovers unite! Appreciate that. That's awesome. The Velvet Belly Lanternshark is found in the Northeast Atlantic Ocean, common in deep water around Norway, Iceland, and British Isles. Also present in the Western Mediterranean and along the west coast of Africa as far south as Gabon. Let's see, 1 to 21 pups per litter. I misread the diet. I thought it said small mammals. I was like, oh my gosh, how does it do that? But no, smaller animals mostly consume invertebrates. Larger animals also predate on small fishes. That makes a lot more sense. I just had this weird image of like lantern sharks leaping out and grabbing like pikas or squirrels or something. So, oh my goodness. Anyway. Behavior poorly understood, rests on the bottom when not actively hunting. So that's actually really cool. This is a behavior that's similar to dogfish. So dogfish can actually take a break, sit on the seabed and do buccal pumping. So, actively pumping water over the gills. It makes total sense that lantern sharks do that too. This is some of my favorite stuff on this website. Reaction to divers, nonchalant around divers in baited situations. Velvet belly lanternsharks are relatively easy to attract to bait. Once they are fixated on the food, they often stay within a few meters of divers, even when caught in the beam of powerful lights. Rarely encountered outside of Norway. Although normally found in water too deep for recreational diving, in certain Norwegian fjords, for example the Namsen Fjord and Trondheim Fjord, this one I think is kind of famous. Trondheim, I think, is a famous one in Norway, if I'm not mistaken. Runoff at the surface creates a layer of silty water that significantly lowers the light level in the water below it. In these areas, velvet belly lanternsharks and other deepwater species, such as blackmouth cat sharks, are found much closer to the surface than elsewhere. So this is really cool. So I'm imagining, because some of these names... There we go. No, that's not it. There was some video... Oh, there we go. No, that's not it either. Sorry. There were some videos that had names that did look a bit Scandinavian. I don't think it's this one. Let me see if I can find one that's a little bit more Scandinavian. There we go. That looks kind of Scandinavian. So this might be one of those environments. So yes, even when caught in the beam of powerful lights. Meanwhile, the video you showed them at the beginning, head bumping the diver's headlights. Yeah, pretty much actually. So this is actually really cool. This is probably one of the fjord environments, and it's amazing to see that. Yeah, this is an environment that it does look like it's the bottom of the deep sea, but of course, if there's divers there, it has to be shallow. Bibia, fish staining, beautiful art to learn full experience to see, but sad to see the shark not being live. I hope the shark had enough time to reproduce and have fun. live a long life before being stained. I 100% agree with that. 100%. That was one thing that I you know, it's like for fisheries research, scientists they do like sacrifice animals or catch animals, and that was one thing that was like I had a hard time with, and I just didn't really enjoy. And like I never do that with sharks, but like it's like you make an interesting like scientists make an interesting argument of we sacrifice a few species, but we're learning more about how they work, and they can actually inform fisheries management decisions that actually save the species as a whole, and that has worked. I mean, that has happened in fisheries management. But it's still like I don't really like the idea of killing sharks at all. Even if it is for science, like it's not something I'm comfortable with. I'm grateful that I've never done that. I've worked sharks up, but we've always released them back into the wild. So I agree. Sorry, that was a long-winded way of saying I pretty much agree. So, yeah. Oh, Vibia. Yes, I'm sorry for being confusing. I thought you meant the oldest species versus the oldest described species. Yes, sorry. I should have clarified that more. Yeah, because I guess technically this gets tricky taxonomically. I actually, you know what? You can, I guess, technically pinpoint the oldest species, and I have no idea what that is. Because some species, I mean, you could trace back the fossil record of shark species, but I have no idea how far back you can go. Let's see if we could take a look at that, actually. So, just want to look at this fjord a little bit more. It's really, really cool that you can have a dive opportunity with these sharks. And actually, I said this at the top of the video too, that with 2 tanks you could probably get 30 minutes. Oh, actually no, that doesn't relate to depth. Never mind. Sorry, I got excited. I thought I was really smart for a second, but I was not as smart as I thought I was. Sorry, don't mind me. I'm just kind of rambling. I'm kind of curious. Let's check out, because Bibia asked a really interesting question, and I want to check this out. Let's see if we can get the fossil timeline. Let's see. Okay, so this is what I'm talking about. And actually, it's really weird how much information Wikipedia has. I know people say you shouldn't be using this, but Wikipedia is actually a really good introduction to some basics in conservation. See, they even have the ice and redless stuff, so it's kind of amazing, actually. But here we go. So, for not all shark species, but a lot of shark species, you can actually get their fossil range, the temporal range, of when we first detected this species in the fossil record. Minges, I feel like the issue at that point becomes a question of, well, what defines a species? Oh my gosh, yes. And that is a fantastic question, and that is a really difficult question. Oh man, that brought me back. That was something that racked my brain a lot. That's a great question, because species are easy to define now. Like right now in this snapshot of time, it's very easy to define species, kind of. Where it just comes down to, do these two organisms, or does this organism share a set of characteristics that allows it to successfully reproduce and grow with, others of its kind? That's basically what a species is. And that's very easy to tell, so it's very easy to describe that. When you go back in the fossil record and you start to see things slowly transition from one species to another, this is where it gets very, very difficult. So as a shark example, you think of like great white shark evolution, where it originally was a mako shark that started to eat more seals, bigger and bigger prey items, and its teeth start to change and get a little bit bigger. Its size starts to change and get a little bit bigger. So there's this weird, very smooth, intermediate pattern of like, wait a minute, excuse me, this is either, I can't tell if this is a mako shark or a white shark. I really can't tell. They just There's traits from both. From a human perspective, it's kind of like a very similar thing where it's like, okay, when did Homo sapiens really appear, and where's the line between Homo sapiens and I forget the one before humans, if it's Homo ergaster or Homo erectus. I forget which one is before, but like where is that cutoff? So it's a very very tricky question. So and it really really bugged me. I think like when I used to live in Florida, there was like a weird period where I just kind of like I had like a weird existential period in Florida where I was like asking some big life questions, and that was one of them. Like, what is a species? Like what? How far is human history? Like, where does it stop between human history and like Homo erectus history? So yeah, it's tricky. It's very very difficult. So and fortunately, kind of fortunately, unfortunately, it's like when you really dive into biology, you get into this really cool gray area of like, scientists, like, I mean, like, even the fundamentals, like, scientists don't 100% exactly know quite when to define life, like, just, which is the foundation of biology. But it's like, we don't exactly 100% quite know where that line is. And the thing I'm thinking about specifically is viruses. Viruses are like, well, they replicate, but they're not really alive. And so are they like this mechanical thing? Are they like, it gets like the lines get so gray, and I find it very exciting now. It's very like, it is very confusing, but I find it very exciting and kind of comforting that even like scientists have had decades of research under their belts. There's debate still, So sorry, there's another tangent, but it is really interesting to think about where it's like, yeah, how do you make these delineations? Like at what point is something kind of tipping the scale a little bit? So. This might sound really dumb, but I think about that with seawater chemistry in estuaries, where I had a debate with a friend about this, where it's like, if you drill down to the microscopic level, you can eventually get to a point where you're saying, okay, this is 1 parts per thousand, this is 1.0000001 parts per thousand, and like, you can start to get a shift in the salinity regime. I don't know. Sorry, I'm really going to the weeds, but it's just like a lot of like, oh, thank you. I feel like it's a good comparison. Yeah, like there's like like maybe the tiniest line between A or B, red or blue, Homo sapiens and Homo erectus. Like there's like somewhere there's maybe a line, and it's just really interesting to think about. So, yeah, so. But, Bibia, sorry, I just saw this comment. Didn't the Greeks or Egyptians people name describe shark? So yes, you are right, they did. But when I'm talking about like scientific names, the system of scientific names, the one that is globally recognized now, was invented by Carl Linnaeus, and I think he. I want to make sure I got his name right, because he's changed his name like. Okay, yeah, it is Carl Linnaeus. So this guy. So Swedish biologist and physician. So let's see. So okay, there. Wait a minute. Okay, yeah, he's changed his name. So Carl Linnaeus, also known after ennoblement as Carl von Linné, also changed his name to. Oh, sorry, not his name in Latin, in rendered Latin, is Carolus Linnaeus. Sorry about that. Okay, so that's why I got confused with. So he didn't change his name. He's had his name Latinized to fit with taxonomy. So sorry about that. But this is the person who invented the modern classification system. So like I said, like Homo sapiens. This is Carl Linnaeus is just a stage name. Oh my god. Oh man, I'm trying to think of like, there was somebody who, Oh gosh, somebody was telling me about a name that was not real, and I'm trying to remember like a stage name. I can't quite remember who this is. It was like it's oh gosh, man, it's on the tip of my tongue. Sorry, is it Millie Bobby Brown? Is it? No, it's not. Hold on, now I'm getting really confused. There's an actor who someone was telling me that they have a fake name. Hold on. It is Millie Bobby Brown. Okay, so sorry. So Millie Bobby Brown is not Millie Bobby Brown. Her name is Millie Bonnie Brown Bon Jovi is her real name, but she just goes by Millie Bobby Brown. So I don't know. Carl Linnaeus, the Millie Bobby Brown of the 1700s. I don't know. Anyway, he Latinized his name, and I got confused, but that's actually really funny. So Carl Linnaeus is just a stage name. But anyway, very famous, very important person in biology because he created the taxonomic system. It's actually really cool. I wonder if there's a way to kind of break this down in. I'm sure you guys pretty much know it. There's no. Okay, he's talking about his life. We don't. I don't want to know his life. I want to know his taxonomy. Okay, so it's basically binomial nomenclature. Hold on. Blah blah blah. So really cool stuff. Undescribed taxon. Sorry, I'm really kind of going into the weeds here. I'm trying to, I guess, taxonomy. I'm trying to find like the hierarchy. Blah blah blah. There we go. Okay, that's what I was looking for. There we go. Okay, can everybody see that? Make sure everybody can see that. This view is really silly. Okay, there we go. Okay, so there we go. There we go. Okay, so you got life, and like I like everybody. I think everybody in the chat probably knows this. Just hadn't known her specific name. Yeah. So there we go. So you have taxonomy kind of breaking down further and further and further. What's really cool is like this is like the basic unit, but in between each of these steps are like even more units. So sharks, for example, are a super order. So it's something that's bigger than an order but smaller than a class. So you've got life, which is all of life. You've got domain, which I think is really cool. Like, so all sharks are in the domain Eukarya, which is cells with a mitochondria, I think is Eukarya. Or no, cells with a nucleus. Yeah, cells with a nucleus. Sorry, this is basic biology. I'm trying to remember. But domain is a huge group of life. There's archaea, there's bacteria. It's interesting that they have 4 things here. And actually, it's actually really cool that in the life category they have these other things. I don't know what they're referring to. But anyway, you have kingdom, which is a huge group of organisms. So animal is a kingdom. Phylum, like chordates in sharks. Chordates. So this includes all vertebrates and a couple of invertebrates. Class, chondrichthyes, so the cartilaginous fish. And then it's really cool that sharks are a super order called Selachii. So once it gets to clad, it gets lost. Yeah, so let me figure out what a clad is again, because I think a clad is like a piece of a unit. It's like a... Hold on. What happened to my search bar? Did I lose it? Oh, there it is. Okay. Clad. A clad, also known as a monophyletic group or natural group, is a group of organisms comprised of a common ancestor. Oh, cool. Okay. So it's actually really... Okay, so a clad would be like... So I guess the best way to describe it is, let's say... So if the lantern sharks... Let me make sure I got this right. Etmopteridae. Okay, there we go. There we go. Okay. Okay, so in lantern sharks, the family is Emopteridae, and there's 3 genuses: Aculeola, Centroscilium, and Emopterus. And each one of these is a clade. It's a kind of group of animals where there was an ancestor that is common to all of them. So there was an ancestral Aculeola that gave rise to the genus Aculeola. There was an ancestral Centroscilium that gave rise to the genus Centroscilium. There was an ancestral Emopterus that gave rise to the genus Emopterus. Getting back to humans, there was an ancestral Homo sapiens that gave rise to all the humans. Or like it's you could say also like animals are a clade, where there was an ancestral organism that gave rise to all the animals. There's an ancestral thing that had all the traits that animals have. So clades are like pieces. They're kind of like they're organizational units, and they can be huge, they could be small, but really it's kind of like, I guess the best way to look at a clade is like a branch of the tree of life, where it's like, say the root of it is all of life, and then the big trunks are like animals, plants, protists, and then as you get further and further out at the branches of the tree, you know, you've got like, you know, reptiles, birds, amphibians, you know, chondrichthyans, you know, like each branch is like a clade. So a clade is like a branch, and you can make it like a big branch. You can make it like a small little, you know, set of twigs. That's probably the best way to look at it, if that makes sense. So yeah. But yeah, for sharks, sharks are the superorder Selachii. The official taxonomic group of sharks is a superorder called Selachii. Sometimes they call it Euselachii. Oh, sorry, did I spell that right? Oh, I did, yay! So, what's kind of cool is that Selachii, I believe, is Latin for shark, and Euselachii, kind of like Eukarya, the Latin root eu, or not eu root, what do you call it? Prefix eu means true. So Euselachii is the true sharks. Selachii is sharks. They're used interchangeably, but it's actually really cool because I think they say true sharks versus like older fossil ancestors. So yeah. Oh yeah, no worries. It's really confusing. Oh, sorry. It's really confusing, Ninja. So no worries. Like it's kind of funny. Like I feel like there's a saying that you're either like a biology person or a chemistry person, and like, you know, it's very easy to confuse them, or not confuse them, but like confuse like the concepts of each field. And I'm kind of rambling a little bit, but like for example, like oxidation and reduction, I would always get that confused. I have no idea which is which, and I don't know what they do. So like I don't know, like that's a long way of saying totally fine. So I want to get back to I really got into the weeds. I love our tangents. It's super fun, but I was really curious about Bibia's question about the oldest shark, and from a fossil record perspective. And there is a way to kind of do that on Wikipedia, because Wikipedia does include the temporal range for some species. So let's check this out. Frilled shark, also known as like a living fossil. Looks like this species came from the Pleistocene. So this species, Chlamydoselachus inguineus, the frilled shark, is as old as the Pleistocene. So okay, let's check out another one, like the six-gill shark, Hixantius griseus. See, Wikipedia doesn't have its fossil range, so it's not going to work for everything. Let's try a Greenland shark, just for fun. Somniosus microcephalus, it might have it. Nope, it doesn't have it. Okay, let's try a dogfish. You should have that. There we go. Okay, so dogfish. They do have the fossil range for it. So spiny pike dogfish or spiny dogfish. 11 million years ago, so late Miocene. So, okay. So that is a contender. Let's try the great white, just for fun, because they should have the great white's fossil record. I feel like that one is pretty strong. So, did I skip over it? There we go. I did. Carcharodon carcharias. Late Miocene to recent. So it looks like the dogfish might be older than the great white from a fossil record perspective. Let's try a mako, because makos are pretty old. Nope, doesn't have the short fin mako stuff. Goblin shark? Sometimes they have goblin shark stuff. There we go. Goblin shark, Miocene to Holocene. So a lot of sharks coming up in the Miocene. Let me double check my fossil timeline. So what was really cool is in that first shot, the frilled shark, which we described as a living fossil, is actually younger than the dogfish, the white shark, and the goblin shark. Dogfish, white sharks, and goblin sharks are actually older as a species than frilled sharks, which is kind of cool. So that's one way to do it. I'm sure there's more detailed studies on a shark's fossil record, but yeah. So that's a great point, Minjas. I assume it'd be a 6 or 7 gill species considering the ancient status of their gill evolution, maybe. So that's a really great point, and this gets into a really good topic about. It's kind of a misnomer to say something's a living fossil, and I think what people are trying to describe, or scientists are trying to describe, is like the body plan is very old. Like this kind of animal has like this. I'm trying to find a right way to describe it. Like I think of horseshoe crabs. Like horseshoe crabs as a whole have been around forever, and a horseshoe crab like thing is a very old body plan. Like a frilled shark, a 6-gill shark like thing is a very old body plan. So in that sense, you can say it's a living fossil. But when you get to the species level, all modern species are modern. Like they're relatively probably the same, like not the same age, but they're relatively like a similar-ish age geologically. Every species that is alive today, is on the cutting edge of time. It is here with us. It's not prehistoric like a T-Rex or something. It's or a direwolf. It's like a living, breathing thing, and it's just as advanced as any other thing. Like they say that hammerhead sharks are advanced, right? But what they're really describing is that hammerheads' body plan have been around, for a little bit less long than a frilled shark's body plan. Like a frilled shark's body plan has been around much longer than a hammerhead's body plan. But the species of scalped hammerhead shark, Sphena lewini, and the frilled shark, Clemodiscus sanguineus, they're both new species. They're both like here with us. They're both modern. They're equally modern sharks. Like they're equally modern because they're alive with us today. If that makes any sense. Like I guess a better way to describe it kind of is like, it's kind of like saying. I don't know if this is going to be a good analogy. Like. I was about to do like a family analogy, like it's kind of like saying I'm a living grandpa, I guess, but like where it's like I'm a young person. I don't know. I'm trying to piece that analogy out, and I'm like no, or parse that out, and I'm like no, that's not gonna work. So, I don't know. I'm trying to find a good analogy. It's really hard to say it I'll have to get back on that because I'm trying to figure out a good equivalent. So humans are living Australopithecus. Yeah. So like that actually might be a better one. That actually might be a much better one because it's like. That's what, Minjas? That actually might be a really good analogy. That might work because it's like Australopithecus is very old, we share traits with Australopithecus because it's an ancestor, but we are a modern species. That's actually, I think that's a good analogy. I think that's a really good one because it's like Homo sapiens is a modern species. Sphaerna lewini is a modern species. Chlamydosaurus sanguineus is a modern species. These are all modern animals, right? But you can say to varying degrees are living fossils, but I think that's a great analogy because I think you get what I'm trying to say, and I appreciate your analogy. That's a lot better than a living grandpa. So thank you. That's a lot more accurate. So, oh my gosh. Well, it's 10:45, so we've got some time left. But if you guys want to cover a specific species next week, please let me know in the chat. I can put some suggestions in as well. And I want to make sure we give the lantern shark some time. I'm of the opinion we are the same species as Neanderthals, Denisovans, and perhaps Erectus. Interesting. So it's kind of cool, living grandpa. Well, it's kind of cool, Bibia, and correct me if I'm wrong, but I believe... So, did some humans, hybridize with Neanderthals, and some did not? Because I thought, European humans hybridized with Neanderthals, theoretically, and then non-European humans did not. And I could be wrong about that, but I am kind of curious. Because it's we definitely have Neanderthal DNA, 100%. We definitely have that DNA still in us. There's been a lot of really cool studies of that. So, but that's actually, I really like this theory, though, that, or this hypothesis, we're same species as Neanderthals, Denisovans, and perhaps Homo erectus. You could be right. I'm not as well versed on human evolution, but again, kind of getting back to the blurred line, thing about when do you make when you make that distinction between species and how tricky it is. I think that's a really cool hypothesis, honestly. So yeah, it's kind of like how mako sharks evolved into white sharks, where or a group of ancient makos eventually grew into the white sharks that we know today. It's kind of it's the same thing where there's that transition period. So that's really cool. I think I want to wrap up. I'll put some suggestions of sharks for next week. I think an angel shark might be kind of cool to do, but let's see. Actually, we haven't done carpet sharks in a while either. Let's see. We did that species. Oh, actually, you know what? I think I know exactly what I like to study for next week if I can find it. Because there was that brand new whaler shark, which I was shocked by. I've never heard of this before. The humans whaler shark, which I also think will be kind of funny because we're talking about human evolution. Carcharines humani? I don't think it's even in this book. So this is a brand new species. Yes, that one. Okay, let's do it. Yeah, I don't even have it in. So this is super new. Okay. Let's do a humans whaler shark. Carcharines humani. I think it is humans whaler shark. Which sounds actually really scary. It's probably a smaller shark. But it sounds really scary because whaler sharks, those are names for usually pretty big, like thinking of bull sharks. Sometimes white sharks can be. Whalers are usually carcharinids, but the bronze whaler is the most famous one. I love this comment, Bibia. I think we are the same. You might be right. You might be right for human evolution. So yeah, we're definitely gonna do humans whaler shark next week because I love that. It's like a nice bow on the conversation. So it's really cool. But great whites, they're sometimes called white pointers. In Australia, they're called pointers. But I can't remember if white sharks can sometimes be called whalers. But whalers, anyway, as a term, refer to large predatory sharks. So it's going to be really cool to learn about a new one, which I've never heard of before. So, and kind of see what it's all about. So next week is going to be the humans whaler shark. So very excited for that. I think to close out for tonight, I do want to do at least one paper. So let's check this out. Environmental. Oh, thank you guys for checking the audio. Thank you, thank you. Environmental preferences and critical habitat for the Velvet Belly Lanternshark in Icelandic waters. So this is by Helga Matina, Stephen E. Campagna, and Clara Jacobsdottir. I don't know if I said that right, but it could be every human's whaler shark. Love that. The Velvet Belly Lanternshark is a small bioluminescent shark that's caught as bycatch in many deep-sea fisheries in the Atlantic Ocean. Using data from 11,000 seasonal research survey tows spanning 11 years, the distribution, relative abundance, life history, and environmental preferences of Emopterus spinax in Icelandic waters was examined for the first time. 9,000, so 8,774 Emopterus spinax were only captured in relatively deep offshore waters of the south and west of Iceland. Females grew to a larger size than males. That's pretty typical for sharks. And reached 50% sexual maturity at a total length of 50 centimeters, so nearly 2 feet. Females at the late stage of maturity and very small juveniles were restricted to the central South Icelandic shelf, suggesting this might be critical habitat for the reproduction of this species. That's super cool. So that's interesting that maybe relative to like other shark species, maybe the central South Icelandic shelf is kind of like the shallow water habitat, because we know that juvenile sharks tend to be in like less complex environments, like shallower water, less predators than big sharks. Big sharks, adult sharks, like to be in more complex environments, like to have a greater variety of prey items. So it's actually really cool if there's like kind of a parallel with the lantern sharks here. Most of the sharks are captured at depth of 400 to 500 meters, a relatively narrow depth range, and classified as a stenothermic warm water species with habitat temperature restricted to about 6.3 to 8 degrees Celsius. That's still really cold, for at least for a human. Celsius to Fahrenheit, because Fahrenheit is the most stupid measurement. I'm sorry, it doesn't make any sense. Fahrenheit is 43 degrees. 46 degrees, so this is very cold for humans. So 6 to 8 degrees Celsius, about mid 40s in Fahrenheit. So I really appreciate that, Bivia. Y'all remember to smash, stay strong, sane, superb, smiling, sweet, stable, safe, and sound. I'll catch you again next week. Thank you, Bivia. I really, really appreciate that. So, at least it's slightly better to know that breeding adults aren't the ones that most often caught. Yes, that's a great point, Minjas. That at least it's not like the most vulnerable, and that's an excellent point for management too. Like the most vulnerable members of the population kind of need the most protection, or definitely need the most protection. And this is breeding like large breeding female members of a species population. You don't want to have those nursery grounds and those areas be subject to unregulated fishing. Like it's important to focus on those areas in particular. This is why nursery area studies are so important for sharks. And they're why they sometimes get really big news attention. Like that whole a couple years ago, there was like New York was thought of as a great white nursery area for a hot second, and then California with the newborn white shark, the famous photograph, which was only last year. They're just so important for shark conservation. The Chesapeake Bay is a nursery area for sandbar sharks and dusky smoothhounds. Along the east coast of the U.S., we have nursery areas for lemon sharks, hammerhead sharks, in Florida, bull sharks. So, it's critical habitat. So I definitely love that comment. Thank you for sharing that, because super, super important. Teleost crustaceans and cephalopods make up most of the diet. There is no indication of decline in abundance over the time span of the survey. However, climate-induced warming of the deep ocean may shift the distribution of the species to more northerly waters within Iceland. So this is really interesting. And by the way, I actually this is definitely somewhat outdated, but I watched Inconvenient Truth for the first time. I know it's a very famous environmental documentary, but watching it for the first time, it was really good. I was very impressed, like how cleanly it presented climate change, and they had a cool section on ocean currents and how water warming affects the deep ocean currents. And it's really cool that it just made me think about that for this article, where they're talking about how with rising water temperatures, you could see a distributional shift in the species where maybe I'm curious like how often the currents may affect the distribution of this lantern shark, where do they set up a natural barrier, specifically, just really quick because I know it's almost 11. There's a surface current that feeds warm water into Northern Europe here. Then there's a countercurrent that pulls down cold water that goes under the Gulf Stream along the seafloor. And I'm curious if any of that relates to this species distribution, where you see how it's here. It lives on the eastern Atlantic, but it doesn't live in the western Atlantic. And I wonder if the currents and how they work kind of relate to that. Deep ocean current map. I want to see if I can kind of show this off, and I'm trying to find a good diagram because sometimes these diagrams kind of suck a little bit. This one's actually probably good, so here we go. Oh, actually, does this work? Don't give me that. Okay, there we go. This kind of works. Oh. I don't know why it's playing music. Sorry about that. What happened? What happened? Why is it playing music? Where's the music coming from? Okay, sorry about that. I'm just going to zoom in on this because this is going to be easier. So, okay. This is really cool. This is a general map of what I was trying to describe, where you have warm surface currents right here in the red. And then these sink down into this like underground layer, if you will, this deep water layer. So it's kind of like, this is like, the red is kind of like your street view. And then the blue is kind of like your subway, right? So in the ocean, you have the warm water surface currents, like the Gulf Stream is going to push up northeast, bringing warm water to Europe. And then it creates this like cool counter effect where cold water sinks, like as the warm water heat kind of like dissipates, the cold water sinks down and kind of like gets sucked into this really cool deep water current. That goes underneath the entire ocean. It rises again into warm water, and it's this like really cool conveyor belt, like this never-ending cycle. Like each, like the physical processes are like amazing here. If you have, as you have climate change, as you have rising water temperature, you will change how these currents operate, and there's a fear that they may shut down if you change it too much. Or maybe they'll just alter their direction. Either way, it's not good because it's going to have a unpredictable effect on the distribution of animals. And that the study on the lantern shark that we were just reading is kind of referring to that. So it's pretty interesting. So thank you, Minjas. Just being able to look at stats like this and immediately jump to, so what if this is related to the way currents work, is huge brain stuff. Thank you. That's a huge compliment. Thank you. I really, really appreciate that. And what's cool is it's just because all of us on this chat, like we're all passionate about the ocean, and it's just like practice and the more like you live and the more you explore, like it's it's cool how these connections form. Like, and again, I know more in my 30s than I did in my 20s. Like to be honest, like which is kind of funny. Like my fiance and I have this running joke. Like 20s ain't shit. It's just like I'm sorry. I never swear on this channel. I'm so sorry. But like it's getting late. I'm so sorry. I usually don't swear on this channel. But point being is like there's a lot to look forward to. There's a lot to still learn. The 20s are fun, but like you keep accumulating knowledge and you keep like learning these really cool pieces, and as you grow, like you make these connections and you're like, oh wow, that's how that works. So where Dr. Just swear, clip it, thank you. So but yeah, but thank you. But I promise everybody on this chat, the more they practice, the more they study, the more they like explore the ocean, like like it's going to be the same, as far as just kind of like making those connections. Super cool. So let's see. I want to zoom forward to see if there's any cool graphs. We do have some photos of the lantern shark, the Velvet Belly Lanternshark. Oh yeah, of course. Someone in my early 20s, I really appreciate hearing that. Of course. There's a lot to look forward to, like as far as just like marine science and the ocean. Like it's just I'm always amazed how never ending it is, and it's super exciting and super encouraging, and it's just like I think as much as you can, just like doing a mix of like any kind of like field stuff, like any kind of, even just in free time, right? Like a mix of like going out and exploring different habitats, like hiking, going to state parks, national parks, like, or just even the beach, just snorkeling and stuff. Like as much as you can like go out and then, couple that with like, reading and, like coursework and, just watching documentaries and stuff. I mean, for me, I generally kind of, in the winter, I usually just kind of like do a lot of reading, and then in the summer I do a lot more exploring. And I feel like it's that kind of hybridization that really is cool, where it's like you go out in the field, you see things firsthand, it's like, oh, okay, and you read about it later, it's like, oh wow, I know what that is now. Like that makes more sense to me. And then as you read, when you go out in the field, you start to kind of understand more like what you're seeing. It's like, oh man, that's amazing. So yeah, sorry, that's kind of rambling a little bit, but yeah, a lot to look forward to. I like personally, I am a lot more plugged into the ocean in my 30s than in my 20s. I've loved the ocean all the way through, but I have a lot more of an instinct and an understanding of it, and it's just earned through just that practice. So which is it's super cool that there's just a lot to look forward to. So here is, I'm glad that they do have distributional maps. So here is, it looks like these are the survey locations. So the areas most encountering, or the highest rate of encounter for these Velvet Belly Lanternsharks in this region of Iceland. So it's pretty cool. It looks like this may be referring to the Mid-Atlantic Ridge. Which is that cool zone where the North American plate and the Eurasian plate collide, which is why Iceland is there actually. It's and why Iceland is very volcanic. It's because it's like right in the middle of the two plates. So, oh, thank you, Witches. I appreciate that. The nice thing is the streams are always there. The live streams are always recorded, so they're in that live tab on YouTube, but they're always replayable. So even if you miss some, they always are there for replay. So let's see. Okay, so this looks like the green circles are the spring survey. So this is kind of more focused on southern Iceland. And then the orange circles are the autumn survey, much wider distribution. And what's really cool, it probably relates to water temperature, where we know that water retains heat for far longer than land. So in the spring, the water temperature is really cold. Like even in April and May, it's still extremely cold. in the fall, like September and October, it's actually quite a bit warmer. Because of how water, it takes a longer time for water to heat up and cool down. Kind of like boiling a pot of tea, right? So it's kind of cool to see that with warmer water temperature, it looks like the lantern shark's distribution kind of expands. So it's pretty interesting to see that. So yeah, Iceland, the place where I find all the velvet bellies. This is really interesting that. Oh, nope. Never mind. I thought this was plotted. This is still interesting, but I thought this was plotted against season. But it is actually kind of cool to see that the size of the sharks plotted against the sex of the sharks. So it looks like the peak abundance of. A lot of the males, they seem to cap out at this 50 centimeter size, but the females, this totally makes sense because female sharks tend to be larger than male sharks, so it looks like the females are, there's far more females that attain a larger size than males is basically what that's showing. So cool. I'm just gonna zoom forward. Okay. Maturity stage 5 shown in blue, maturity stage 6 shown in orange, all mature stages 3 through 7 shown in magenta. Maturity stages 5 and 6 are both pregnant females. Okay, this is interesting. So the blue and orange circles are showing pregnant females, and the magenta circles are showing sexually mature individuals. So it's kind of interesting that the actually pregnant females are more concentrated in southern Iceland. And then there's sexually mature individuals in western Iceland, but they're not pregnant. So it's pretty interesting to see. This is a really cool study. I'm gonna put this in the chat so that people can read it. Let's see. You can see a peak abundance in autumn, so more lantern sharks are being caught in autumn. Okay. And should hop off in a little bit because I think there's so much to study that probably won't be able to cover it in depth. Yeah. All right, I'm just gonna give this one more shot. Oh. Now this is interesting. Okay. So number of sharks caught plotted against year and incorporating season. So that's actually really fascinating. So green is spring, orange is autumn. Yeah, starting in 2010, you start to see a higher amount of individuals peaking at 2018. Then you start to see a crash a little bit in 2019 and 2020 spring. And then 2020, 2021 kind of go back to this same number of autumn adults. So I actually am curious about this. One, I'm curious about why there's a higher abundance of animals being caught in 2018. Does that indicate an increasing population or a change in sampling effort? Probably increasing population, because it seems like there's a trend line. But what's interesting is like this crash around 2019, 2020. What's kind of freaking me out is like, well, okay, the spring 2020 crash. I wonder what happened in spring of 2020 that like may have affected people getting together and participating in research surveys. I wonder, what could have occurred? And I like this drop. I am actually very curious if it's related to coronavirus pandemic and maybe some protocols for sampling. I don't know. And like I think I'm just gonna do a control find for COVID just to see. Oh no, I guess I can't control find in this article, can I? So, but I'm very curious about this. This drop in data point. I think this actually might be I have a suspicion this is probably COVID related because look at this. The fall survey number is actually comparable to the other years. This spring survey number is weirdly low, and it just correlates so nicely with like the beginning of the lockdown in 2020. So I'm kind of curious if that's what that is. So not 100% sure. So yeah, I love that hypothesis, Minjas, but then I love that pivot. That's really funny. So, yeah, it's kind of cool. It's kind of cool that data, like when you correlate data with things, it's like it's just a guess. I'm not 100% sure, but I think it's so unusual that it could be related. So, but anyway, I think with that, because I know it's a little bit past 11, I think we'll wrap up for tonight. But guys, thank you so much for watching. Really love this episode. This was a lot of fun to go through, like kind of explore this species, and I really appreciate that. I feel like the other lantern shark episodes we've done, we've kind of covered bioluminescence quite a lot in detail, but it's really nice to kind of have a variety of topics for this episode relating to this beautiful shark. So. And just sharks in general. So I had a lot of fun covering the Velvet Belly Lanternshark with you guys. So thank you so much for watching. I hope you all have a great rest of your week and continue to enjoy the warming weather. The water temperature is continuing to rise, so we're starting to see some really cool things migrate up the coast. So hopefully you guys have a great rest of your week and have some opportunities to go out and see nature and explore. And we will tune in next week for the very fast and iridescent little man. Yeah. We will tune in next. Love that comment. We will tune in next week for the humans whaler shark, which I'm really excited. We're on a roll too, because I love that we did the river sharks last week, a deep water lantern shark this week, and now we're going back to the shallows to see a whaler, like a Carcharinus. So I think it's going to be a cool mix. So, but thank you so much, guys, for being here. I hope you have a great rest of your week, and I will see you next week for the humans whaler shark. Thank you always for your comments. I really appreciate that, and peace out, guys. Cheers. We'll see you soon. Bye.